In this problem, we're going to consider the linear programming problem where we maximize 5x plus 12y, subject to a number of constraints. We want to find the optimal solution, write this as a matrix problem, and find the dual problem. Okay, so before we write this in a matrix form or find the dual problem, let's look at the feasible set. The feasible set, you can do it by hand, or you can use some sort of graph for it. It's easy enough to find by hand, but just so that I don't have to waste time doing that in this video, here is the feasible set. So the feasible set has a number of points that we need to look at. So the points that we need to look at are obviously the origin. We need to look at 10, 0. We need to look at 9.33, comma 1.33. We need to look at 6.3, and we need to look at 0.5. And we want to find the objective value there. And of course, that objective value is p equals 5x plus 12y. Okay. So when we plug in the objective function value, for the first one we get 0. For the second one we get 50. So those ones are pretty easy. The next one, you can calculate it, it's right around 60. The fourth one is 66, and the last one is 60. So obviously the maximum value is 6.3. Again, a good graph will show you that pretty quickly. Now, how do we talk about this problem in terms of a primal and dual problem in matrix form? So in matrix form, we're looking to maximize our objective function here is 512 times xy subject to 20, 10, 10, 20, 10, 30 times xy less or equal to 200, 120, and 150. And we know that x and y are both greater or equal to 0. Okay, so this problem is of the form, this is our C transpose X, and the second part is our AX greater or equal to B. Now, in this case, it's less than or equal, so we're going to need to flip that. But we'll get to that in a minute. Okay, now, if we look at these two problems, our dual problem is going to be minimum or minimize B transpose Y subject to A transpose Y less or equal to C. Okay. So we go ahead and Let's make the adjustment here. This needs to be greater or equal. This is less than or equal. So we're going to multiply through by -1. So it'll be negative A and negative B. So in this dual example, instead of B, we have negative B. So it'll be negative 200, negative 120, negative 150 times Y. That's what we want to minimize. Subject to the constraints, A transpose Y equals C. So again, we're not dealing with A, we're dealing with a negative A here. But in any event, it'll be -20, -10, -10, -10, -20, -30 times Y1, Y2, Y3 less or equal to our C, which was 512. And that's our dual problem.